Hi, this is Josh Lane from Sensoleak Global, and I wanted to walk through another case study. This is from a crude oil client of ours, and they provided us with a number of different synthetic data sets, included both nominal and abnormal operating conditions for this pipeline. And they provided just the SCADA data, no engineering data. And really what that does for us is that it does not allow us to get to the same performance metrics that we would like. So you'll see here our detection percentage is not quite as high as we'd like, and our false alarm rate is a little higher than we'd like as well. Now, there is a coupling here that we do have. We do have the sensitivity and the flexibility within our software to go through and modify this, such that if you're in a highly populated area, you would want to have a higher detection rate, but that also presents the potential for more false alarms. And that's because you want to make sure that you catch everything. You're okay with having a couple of false alarms because you're worried about the loss of life. Whereas in a more remote location, the cost of going to investigate those false alarms is higher and is more problematic than the potential for other losses because it's in a remote area. So that's some of the information on the left-hand side of this particular slide. Look at some of the plots that we have here. So this plot over here in the top right, this is showing you not just the fact that we're looking for thresholds. We're not just looking for a single number for our anomaly detection. We're looking at, we're not even looking for a box or a region. We actually have a threshold function that varies over time. So this corridor here is what we're looking for. This is our corridor of normalcy. So anything inside this corridor is normal operating conditions, and anything outside, so these red dots, these are showing you points of abnormality. In this case here, we're just looking at the flow versus the volume change. And then looking at this in a couple of different fashions, these are some of the actual anomalies that we did detect, just to kind of show you some different ways of representing information. So in this case, we have green represents normalcy, yellow is kind of the start of things going abnormal, and then red is more of an obvious anomaly of some sort. So it kind of gives you an idea of how some of these different things could be visualized, could be represented, whether this is an intermediate product or this is actually a display for the actual operators. You have that flexibility to pick and choose what that looks like. But these are some examples of showing what some of these anomalies look like, how we can represent them, and really how we're going through and doing the analysis.